What is the best way to implement a VAE? Imagine creating a machine that can learn to generate new images, sounds, or data that look just like real things. That's what a variational autoencoder, or VAE, can do. But how do you build one that works well? Let's explore the best way to do it. First, a VAE has two main parts. The encoder takes your input data and compresses it into a smaller, more manageable form called the latent space. It learns to describe the data with a probability distribution, usually a Gaussian, by figuring out the mean and variance. The decoder then takes samples from this distribution and tries to reconstruct the original data. This setup allows the model to generate new data by sampling from the latent space. One of the most important tricks in building a VAE is the reparameterization trick. Since you want to train the model with gradient descent, you need to make the sampling process differentiable. Instead of directly sampling from the distribution, you sample a random noise from a standard normal distribution and then scale and shift it using the mean and variance. This way, the whole process remains smooth and trainable. Training a VAE involves balancing two goals. First, the reconstruction loss measures how close the decoder's output is to the original input. Usually, this is done with binary cross-entropy if working with images or mean-squared error for continuous data. Second, the Kullback-Leibler divergence pushes the learned distribution to stay close to a standard normal distribution. This regularization helps the model generate smooth and meaningful variations. To implement a VAE successfully, use stable activation functions like softplus or relu, and add small constants to prevent numerical issues. Keep your code clean by organizing your encoder and decoder as separate modules, and use libraries like PyTorch's torch distributions to handle the probabilistic parts. Monitoring your training with tools like TensorBoard can help you see if your model is learning properly. Start with simple datasets like MNIST to test your model. Make sure your encoder and decoder are not too complex, which can cause overfitting or training instability. Use enough training epochs, around 50 to 100, and check the loss curves to see if they stabilize. Adjust your learning rate if needed, usually starting around 0.1. The real power of a VAE comes from its ability to generate new data. Once trained, you can sample points from the latent space and decode them into new images or sounds. This makes VAs useful for creating art, improving data augmentation, or even filling in missing parts of data. In the world of generative artificial intelligence, VAs are a key tool. They form the backbone of many creative AI systems like DALL-E or Midjourney, which generate images from text prompts. By understanding and implementing VAs properly, you open the door to building your own AI models that can produce realistic and diverse content. Remember, always keep your training stable and your code clear. Use the right loss functions, regularize your model well, and test on simple datasets first. With these steps, you'll be on your way to creating effective variational autoencoders that can do amazing things in the realm of deep learning and specialized artificial intelligence.